next, but there we go. So anyways,
one of the things I found with the Zygu with the filters, when you change bands,
yeah,
after you tune, cycle through your preamps. So for whatever reason, it makes them screwy. Either turns them on, turns them off, and you're not sure which one you're actually on.
good tip.
And leave your ACG as auto. Just found that kind of through YouTube videos and different other posts and own experience, it just works.
Awesome.
Unless you're doing the digital and then you got to turn it off.
Yeah, I haven't set up the digital yet. I've got the interface, so I'll have to do that. So anyways, I'll let you guys know how it goes. So Rob, is John all set to share his screen for the presentation tonight?
John, I've made you co-host, so you should be able to share anything you need.
Great, thanks. Let's give that
Whenever you're ready, John.
All right, we'll give that just a quick try. Screen. Okay.
I'm probably going to shut my camera off. I got to putter around, but I'll be tuned in and listening. So have a good night.
Okay, so you guys see that?
Yes.
Sir.
Yeah, beautiful.
Okay. Okay, good. All right. So we're gonna, whoop, I shouldn't have closed that. Well, all right. So we're gonna talk about Arduino tonight. Arduino is a microprocessor that you can program, and it's a lot easier than you think. I'm just gonna really skim over the basics tonight. We're not gonna really get into any deep weeds and stuff, but let's see. I'm going to switch my camera here, and okay, and I think you can all see that now. And that's an Arduino board. How do we do this here? There we go. So that's the most basic. One is your best choice to get started with is called the Uno, UNO, Arduino Uno. And if I come out a little bit, there's a breadboard there and you can just see all kinds of wires plugged in. And those wires connect things to the Arduino. That happens to be right there. This. Let's see, can we do, okay. So this guy right here happens to be a Bluetooth module, and with your phone or other Bluetooth device, you can connect and talk to the Arduino when it's hooked up. You can see a couple of LEDs there. There are all kinds of things that you can get to connect to the Arduino. There's well, of course, LEDs, and there's a Bluetooth, and you can get real-time clocks and temperature sensors and GPS sensors, and you can get micro SD card readers and motion sensors and distance sensors and all kinds of things. There's a whole bunch of Arduino starter kits, and a lot of them are pretty good, and they give you a bunch of stuff. Those wires, by the way, are called DuPont, just like the chemical company, DuPont wires. And if you're going to play with Arduino, you're going to want those. You can want some little breadboards like that. Breadboards are all kind of standardized as 1/10 of an inch pitch. So each hole is 1/10 of an inch wide. I'm not going to really get into the weeds of how they're all wired and stuff, but the little breadboards make it very easy to put stuff together. And when you get the DuPont wires, and they're dirt cheap, I mean pennies. You want to get a bunch of different male, female, and female, and just get a selection and hopefully in different lengths. So that's the hardware basics, really. And there's so many other things, and whatever you can imagine, anything that would send some kind of a electronic signal is probably made for Arduino. So we're going to look at a very basic program. And let's see, we got to do this. Got to do this because, like an idiot, I closed it. Okay. So, and I'll post this information in a minute. The software to do it is free, and it comes with comes from the link for that is called Arduino.cc. Arduino.cc, and I'll put that up in the chat. Let's see. Well, I'll do that in a minute. But it's Arduino.cc, and you can download the development environment for free. So, okay, so we're gonna do. Whoops. Okay, so what you start with.
Marchie.
Yes, thank you, Rob. What you start with is, where do we go here? Okay. Okay, so this is, and everybody can see that, I hope?
Yep.
Okay, so you've got your void setup and your void loop, and the setup is where you set things up, and then the loop is where, and that's just going to keep going around and around and around. It's going to keep running through that loop and do what you tell it to do. And that's the basics of it. So let's see. So we're going to, okay, so we're going to look at a very basic sketch here. Programs are called sketches. Okay, so here we have, everybody can see that? Yes, okay. So, and there's a couple of basic principles that you want to understand, okay? What we're going to do here is blink an LED, and it's the simplest thing you can do. And Arduino commands, it's all case sensitive. You got to be careful about that. And I think you can probably see, okay, what we're doing here, int blink rate equals 500, int LED pin equals 12, case sensitive. But what we're doing here is, and then anything, anything after you put a double slash, anything after that is a comment. And the program will, the processor will ignore anything after a double slash. And you want to, I really didn't do it for a lot of these that I'm going to show you, but you really want to comment your stuff, because when you go back to it after 6 months or a year and want to fix it, change it, alter it, trying to remember what you did can be a challenge. So up here, we're going to set variables, and a variable is just a name for something else. It's a name that we're going to use, and you're going to see, for example, we set blink rate, okay, as being 500. Arduino has a timer in it, and the timer is in milliseconds. It's also got a microsecond timer, but anyway, 500 milliseconds. And that, so we've got 500 milliseconds, that's a half a second. So we set blink rate, and now down here, you can see we're going to use blink rate right here. And we're going to use blink rate right here. And as your program gets more complicated and more involved, you're going to use that same variable over and over and over. All I have to do is change it here once, and it changes all the way through. And that's a very handy thing to do, and that's very powerful. There are other uses for variables too, but that's the basics on that. And then same thing with, we're going to set the LED pin. What we're going to do here is blink an LED. So the LED pin, I have the LED set on pin 12 and ground. And then we have to set that pin, okay, in our setup. So pin mode, and you notice here in is in blue and the rest is in black. In is in blue and black. Pin mode is in orange. Okay. The Arduino commands are case sensitive, and if you type them right, generally they change color, and that lets you know that you did it right. So here we're saying pin mode, and see how that M in the middle is uppercase. Okay. So we're going to write for output, we're going to say that that pin, the LED pin, which we define back here as 12, okay, right there. Okay, we're going to say that that's going to be output. That means we're going to send something to that pin, and there we go. And now in our void loop, it's going to keep going through these commands time after time after time. So you put your main code here to run repeatedly. So we're going to digital write, and again, you see how it turns orange, and the LED pin, which we defined as 12, and high. It's a digital pin. It's either high or low. So we're going to set that high. We've got the LED connected between pin 12 and ground. So we're going to set that digital write. We're going to set that LED pin high. We're going to wait for the amount of milliseconds that we set back up here at 500. And we're going to pause for half a second is what that means. Then we're going to turn that pin low, which turns it off. And we're going to wait another half second. And then you see how void loop starts with that curly brace. And function, whatever you're going to do in a function, like setup, like loop, and we'll get into some other functions later, is in between the curly braces. So, and you got to keep your curly braces straight. And Arduino, again, the IDE, Interactive Development Environment, I think it is, helps you keep track of that, because if you highlight this one, you see how that one, that's the mate to that. And when you start getting more complex, you'll have nested curly braces, and you can always see which pairs match, if you understand what I mean. So now what we want to do is we got our program written, and what we want to do is upload it, and you can verify it here and check that it's basically okay, that you followed all the syntax rules. You can just upload it, which is what we're going to do. And you can see down here it says compiling sketch, and we got an error. It turns the unhappy orange color. You'll see that a lot if you're like me. Exit status 1, expected a semicolon before delay. Okay. So, and here we go. It highlights this line, and before delay, just about every command ends with a semicolon. And I forgot to put it in here. So I'm going to put it in here. And now I'm going to try and upload it again. And it's compiling the sketch. And now it's giving me the happy giant dance, and it likes everything I did. So.
John, can I ask a question?
Yes.
if you had used the little checkbox up there to check your thing, would it have found that error before you sent it up?
Yes, it would have.
Thank you.
Absolutely, absolutely, it would have. It you can use that to check. It's because you always think you did everything right. It's just a simpler to, and then you find out you didn't. So let's see now. What we got to do is get. Okay, so we got to go.
Quick question, John.
Yeah.
Yeah, I hope I'm not getting ahead of things here, but on blink rate, which is where you set your variable, and I know you said if you change it in one, it changes all the way through. If you had a condition later on in your program, let's say you were doing more with it, and under certain conditions you wanted to change the blink rate, would you use, say, blink rate 1, blink rate 2, something like that to differentiate them, or how would that work? Or is blink rate a fixed command?
It's going to depend on what you need, but you just using variables can change within the program. Variables can change, and they often do. Okay, they certainly can and do change, and often, and that's often you want to do that. That's so it just, you can, when you do that initial setup, that, let's see, let me see if I can go back. When you do that initial setup, you can set you can initialize the variable to say 0, or you can initialize it to whatever, and then down through the program, things are going to change that variable. That's very, very often the case, where things are going to change that variable as the result of a calculation or the result of some other process as a result of reading. And we're going to see that in a little bit later. We're going to see that.
Okay.
Okay, so now let's see.
Does it have a if logic? If this, do that?
Oh yeah, that's we're going to get to that too, John. Okay, so let's see. I think you can see now the green LED blinking. Okay, and that's what we just uploaded. So let's see. Okay, so everybody can see that the green LED is blinking?
No.
No?
No, it's still on the code. Where is the?
Change your view to side-by-side gallery and you'll be able to see it.
Let's see.
Just keep talking, John, and then your blink comes up.
Okay.
Oh yeah, I see what you mean.
All right.
Okay.
John, you don't have to do anything. Just keep going.
Okay. So you see it, you see the green LED blinking. Okay. So now we're going to, okay. So now we're going to go to the next sketch, which is, okay. So now this one here, and everybody can see that now? Okay, so this one here now, this is not the same LED. We're going to blink a different one, and it's a 2-color LED. It's red and green. Okay, and so now we've got it's 2 leads on this one, and if you hook them up, if you connect them one way, plus to minus, if you hook them up one way, it's red, and hook them up the other way, it's green. And those are just so cool. I love them. So now we've got the basic 2 colors. And again, our blink rate, we set it at 500. we've got now the red pin and the green pin, as you can see. Red pin, green pin, output. And try and name your variables, things that make sense to you and that you're going to remember. Okay. And again, red pin, green pin, we're going to set them up for output. And now what we're going to do here in the loop is we're going to write the red pin high and the green pin low. And again, they're digital pins. So this is going to turn the LED on red. And then it's going to wait for the blink rate. And then it's going to do the opposite. Turn the red low, the green high is going to turn the LED green. And then wait for the blink rate. And we're going to upload that. Okay. And now you can see the LED, and I put a ping pong ball, put a little hole and put that over the LED so it shows up better, but that's why it looks like a big globe, but that's just a standard old ping pong ball. So now the interesting thing about the red-green LEDs is, and here we go now, we want to change this variable. If you switch them really fast, well, we're going to see what happens. Okay, we're going to change that 500 blink rate, and we're going to change that to 50. See, now all I have to do is change that once, and it's going to change it here and here, and the program could go on for another 500 lines. It's going to change that number from 500 to 50 all the way through. So let's upload that. And you can see now it looks yellow, but it looks a little flickery. So we're going to change that to 10. And there we go. I think there's probably still a little camera artifact there of, looks a little flickery, but I don't see the flicker here at home. The camera's just a little bit, but it's doing it much faster than your eye can follow. So that's a yellow, and everybody sees that's yellow. So we've got, now we can do red, green, and yellow with it. Okay, so and that's just a little bit further along of what we were doing before. Now the next one we're going to do basic blame. Okay, now now in the what I've wired in here, and you can see it's just a basic pot, nothing fancy, a basic 3-terminal pot. And I've also put a switch, do everything backwards here, just a basic switch, and they're wired into the board as well. So what we're going to do is we're going to read that pot, and the pot is set up as a voltage divider. Arduino has both digital and analog, quasi-analog ports. And the analog ports, maximum voltage on the ports, by the way, is 5 volts. So you got to be careful about that. I'm setting that pot up as a voltage divider. I'm starting with 5 volts right from the board, so I don't have to worry about that. But the ports can read, it'll read up to 1024 steps. So it's going to take that basically take that 5 volts and slice it up into 1024 little slices. Okay. And so now you can see I've added a voltage, I've added a variable rather called pot read. And we've still got our, okay, we've got now the pot pin, and that's input because we're reading that from something outside, and that's coming set up as an input. Red pin, green pin are the same. And then serial, there's a serial port built into the Arduino, and it's basic. It's you got the 3. You need 3 for serial communications: TXD, RXD, and ground. TXD is transmit data, RXD is receive data, ground. So the TXD is what goes out of the Arduino, RXD is what comes into it, and ground. So you got to open up that serial port first. And again, notice that it's turned orange when I type that in. 9600 is the baud rate. There's a lot of different, pretty much the full gamut of up to, I don't know, up to 115,000 or something. For most things that you're going to do, 9600 is tried and true and reliable. Okay. So now, here's what we're going to do here in the loop. And we're going to, okay, analog read, we're going to read that pot pin. And then, and we're going to put that in the variable called pot read. Remember, we set that back up here. So we're going to set pot read to, we're going to analog read the pin. Now we're going to set that, we're going to map. We're going to take that, excuse me, let me get a sip of water here. Okay, we're going to take that pot reading, which could be anywhere from 0 to 1023, and we're going to map that. We're going to cut it up into 6 slices, 0 to 5. You got to remember to start from 0 counting, because that's how computer guys do it. Okay, so we're going to map it, or we're going to slice that those 1024 steps, and we're going to take them into just 6 steps. And now we're going to print on the serial port, and the quotes, we use the quotes and we use that space there, but the quotes mean that it's going to be text that we're going to print. And then we're going to serial print ln, print line, so that we're going to print voltage level is, we're going to print what the pot reading is, and then print ln means we're going to go to a new line for the next print command. Okay. And then we're going to, okay. So that's, the serial printing can get to be, the serial port operations can get to be a lot more complicated, but that's basically, and there's a way to, let's see, let's show that right now. We go to tools and serial monitor. Oh, no, we didn't upload it first. So okay, so we're gonna upload this. So we got something to look at, and it's compiling, and it's back, and it's done. Okay, so we're gonna go to tools and serial monitor and new share. Okay. Can you guys see that serial monitor now?
No.
Does that thing say 21, John?
This voltage level is, oh, wait a minute. Is that it?
Oh, okay.
Okay, you see voltage
Yeah.
level is
Yeah.
2.
right now. Okay. So I'm going to turn the pot and okay, and we went to 3 and 4 and it's not going to 5 and 3 and 2 and 1. 0, 1, 2, 3. It's probably how I set up the readings on this one. So you could also see the LED changing with it. We're going to get to that right in a second. Okay, so we're going to close that. Okay, so okay, now there's a couple of important things coming up here. Okay, so if the pot read is greater than 4, okay, that's why it didn't show up. Okay, so now this is the if statement, and who asked about that? I think John did. Okay, so here's an if statement, and if just means that if this is true, okay, now it's going to do something called green flash, and I'll show you that in a second. Okay, else if, so if the pot read is not 4, and if you're doing these nested or successive if statements, you got to give it some thought about how you set up the levels, because if you start with if it's greater than 1 or greater than 0, it's always going to be greater than 0. Whether it's 1, 2, 3, 4, it's always going to be greater than 0. So you start with the 4, then it's going to do something called green flash. And if it's greater than 3, greater than or equal to, okay, then it does something called green. Greater than or equal to 2, it does yellow. Greater than or equal to 1, it does 1. And then else, the last else, if none of the above is true, in other words, now it's got to be 0. It's going to be doing something called red flash. Now, down here, you see that that's my whole void loop. Okay.
Hey, John, I'm still seeing just the COM monitor on the screen.
Same here.
Oh.
We're not seeing the, we're seeing the serial port monitor right now.
Okay. Let's see. How's that?
There you
Will
go.
you be in?
Better.
Okay. Now you see it?
Yes.
You
Just
see
don't
the
say,
sketch?
just don't say now you don't.
Okay. Okay, I'm sorry. Thanks for letting me know that. Yeah, I'm not great at this stuff, so let me know if I screw up here. Okay. So, okay, so here we're going to read that pot, and here we go. As I said, it's going to analog read that pot pin, which is going to be from 0 to 1023. Then the map statement here is going to slice up that 0 to 1023. It's going to divide it up into 0 to 5. There's other ways that you could do this. I find this convenient though. So now it's going to print voltage level is, and everybody saw that already. Okay, delay. Now, okay, this is the void loop. Okay, and that goes from here, the opening curly brace, and you can see those curly braces all the way down. And here's the closing curly brace of the loop. So all of this stuff here is inside the loop. And here we go now. Okay, if the pot read is greater than or equal to 4, it's going to do something called green flash. And you can imagine what that is. If it's greater than or equal to 3, it's going to do green. Greater than or equal to 2, it's going to do yellow. Greater than or equal to 2, it's going to be red. And the last thing is, if it's greater than, if it's not greater than or equal to 1, and essentially if it's 0, it's going to be something called red flash. So now here's, okay, here's a red, and this is just, doesn't matter what order I put these things in, but here's a function called red. And it's very simple. We saw this before. This is going to turn the red pin high, green pin low. It's going to turn on the LED red steady. And so that's going to be, if it's greater than or equal to 1, it's going to call the function called red. So there's that function. Same thing, there's a function called green. There's the green flash, and we saw basically how that works. Turn the green pin high, red pin low, delay 250. And I could have used the blink rate, and I just didn't. I was too lazy. So this is a quarter second, 250 milliseconds in the delay. And then the red, that's green flash doing it green. And we just flip the pins around and do it yellow. I'm sorry, do it red. And then there's the yellow there. So depending on what those parameters are, what that reading is on analog read, it's going to call one of those functions. Okay.
Question.
Yes.
John, what's that void? Is that a command or that's just?
Void means that you're not, it's not going to return anything to you. I'm not a real expert on this Arduino, a real pro on it. But it basically means it's not going to return some value that you're going to use elsewhere.
Okay.
Okay.
So it's an isolated function. It kind of sounds that way.
Yeah, it just does exactly what it's going to do here. If you wanted to return something instead of void, you put what it's going to return, what value it's going to return. And then you got to tell the rest of the program how to go get that information.
Another question.
Yes.
Thanks. Does Arduino follow all of Boolean algebra, or is it just they have selected commands that they follow?
I believe it follows all of it. One thing that's, let's see.
So it's got for A equal 1 to whatever, then next or whatever. It's got all those types of statements, or?
I'm not sure. Does it have which?
Just like all of the Boolean algebraic statements. Like basic, almost like basic.
It follows C language, C++.
Yeah, it's a subset of C++, I guess C++, more easily.
Well, I'm seeing a for then loop and some other stuff. So that to me means that it's Boolean, but maybe I'm wrong.
Yeah, the for, we're going to get to the for loops and
Else if.
Yeah, well, the else if is in here.
Yeah.
Here's the else if, and we're going to just scratch the surface on the for and whiles. And that's going to be, so it does one thing to, and I probably don't have a good example of it here, because I used greater than equal, but one trap that you'll fall into undoubtedly is the equal. Okay, you use a single equal to set something. Okay, here we go. Pot read equals. Okay, so we used a single equal sign there. If you're doing a test, if something equals this, you have to use a double equal sign. You have to do equal equal, and that will trip you up and it has tripped me up many times, because if you say, if this equals that, well, once you say this equals that, that becomes true because you said it. And now that if statement is always going to be true. And so you got to be really careful about that. You have to do if this equal that. And that's just something that you got to.
Equal is not a statement then.
No, equal is a statement. Equal is a condition. Equal can be true or false.
So it's a test. It's a test.
So it's a test.
Yeah.
Just like, just like right here, I use greater than equal,
Right.
greater than or equal to. Okay. Well, if I wanted to say if that pot read is exactly 4, then I would say equal 4. If I said if pot read equals 4, that's always going to be true.
Right.
And it's never going to see if you in an if statement, if this is true, it's going to do this. Okay, if pot read is greater than or equal to 4, it's going to do green flash. If not, if that's false, it's going to ignore that and go to the next statement.
You got to remember your syntax.
Yes. So you got to just be really careful about your equal and equal. It's a common, very common trap. So if this is true, if this here is true, it's going to do this. If it's not true, it's going to ignore that green flash and it's going to go to the next one. And if that's true, it's going to do, if it's greater than or equal to 3, it's going to do green. If not, it's going to ignore that. And else if, I mean, it's just like in English, else if that's true. And the last else is if all the other ones are not true, it's going to get down to this one and it's going to do red flash. So now we're going to do, I'm going to turn this pot again.
Yeah, more.
Okay, and let's see, I'm going to stop the screen share, I think, right? Okay, and you can see the red ball blinking. Okay, so as I turn the pot, okay, it goes from green flash and then it goes to green, and then it goes to yellow. And as I turn the pot down a little more, it goes to red, and then red flash. So you can see that it actually works. Okay, so that's and again, we saw that on the serial monitor. We saw the voltage levels. They correspond exactly to that flash. Okay, so we're going to go to one last little more fancier thing. Okay. Okay, so here we go. And this one, okay. Now I added, as I mentioned, there's also a switch that I added that's wired in. So, and now we have and again, we set up ints. Variables, by the way, I should mention this at the beginning. The 3 most common by far variables you're going to use are ints, floats, and strings. Ints are your whole numbers, 1, 2, 3, 4, 5. Floats can have decimal points in them, 1 1/4, minus 1 1/2. They can be positive or negative. So floats take up more memory and slow things just slightly. And the Arduino runs very fast anyway, but unlike an int, never going to have a 5. So we for all these things. Floats, if you're doing math, where the numbers, the results can, or the inputs, or the float, or the results, anything but whole numbers, which in most cases they can be, you're going to want to use floats for that. And remember that numbers can be text if you want them to be. You won't be able to, if you define a number as text, you won't be able to do any mathematics with it. But if I was going to put if I was going to print a message that said 73 N1GNV, like I do on my email, for example, well, that 73 can be text because I'm never going to treat it as a number. So numbers can be text as well, but strings are text. And if you remember, when we put when we had the printing the voltage level, the text was in quotation marks, and that tells, you can do that same thing with define that variable. You can say string and a voltage message, and then put that in text. You can print that string as a variable, just as you would print what the pot reading was, as we saw before. Any questions?
I got a question.
Yeah.
Yeah, John, what if you have a syntax error in that, does it upload and try to run it and crash, or it refuses to upload it, or what happens if you have
remember we saw that in the first one I did, where I left off the semicolon. I did that on purpose, by the way. I left off the semicolon and it just said there's an error.
So it wouldn't let you load it?
It wouldn't load it, right.
Okay, cool.
So it gives you, sometimes it gives you a really clear hint. In that case, it said expected a semicolon before the command, and it highlighted the line where it was expecting something right before that. Sometimes the error messages can be a little bit cryptic, and you got to really dig to understand them. But generally, it's errors. Most of the errors are things like not putting a command in the proper case. Or just a typo in a command, or just not putting in the proper case. But in that case, it won't. If I put in pin mode without that uppercase M in the middle right there, it's not going to turn orange. Okay, so you can see that now it didn't turn orange. So you would expect it to turn orange because it's a command, and it didn't, so something's wrong there. And there you see I changed it. Okay, so, but it will, if there's a syntax error, it will refuse to, it'll tell you what's wrong, and it won't load it up. If there's a logic error, it'll load it up, and then you'll get results that you're going to scratch your head and say, what? And then you got to start like if you forget a double equals and just put in a single equals, and again, that's very common. And if you do that, your if statement is always going to be true, because you have said, when you said if this equals that, not if this equal that. When you said if this equals that, you set this to that, and then that's always going to be true. Okay, and that's a common error. Forgetting a semicolon at the end of the line is a common error, but it tells you that, and that's always pretty clear and easy to fix. So, okay, so we are going to set, we got our red pin, green pin, the pot pin. We added the switch pin, and the switch is on pin 11, and it goes from pin 11 to ground. And we set our pot read that we had before. There's our blink rate. Okay. And there's our pin mode, input, output, output. Now input, pin mode on the switch pin, we use input pull up. And input pull up means it's going to set that switch high. Okay. When the switch is off, that pin is going to be high. When you turn it low, it's going to pull that down to ground. But by pull up, it doesn't float. It's definitely pulled up to 5 volts. So when you turn the switch on, that's going to take that low to ground. Okay, but that's why we use input pull up on that. Okay, so now here we go. Okay, and we're going to write. There we go. Now this is a while statement, and while means exactly that, while. Okay, and here we go. Here's a double equal right here. Okay, so while the switch pin is high, in other words, as long as that's true, okay, it's going to do what comes after it. If that's not true, it's going to ignore everything else, and it's going to get, in this case, it's going to get all the way to the bottom of the loop, and it's going to come back up around, and it's just going to keep looping around, testing that while statement every time it goes through. And it goes through in picoseconds, I guess, or something. So it's going to just keep going through. And as long as that switch is high, and again, when we turn the switch on, it goes low. So while that's high, okay, in other words, the switch is off. In this case, that's just the way I wrote it. But while that pin is high, which we set earlier, it's going to go to the next statement, and it's going to do the pot read like we saw earlier. There's the map. It's going to print the voltage level is. It's going to print the pot read variable, and then it's going to, and again, we go through if the pot read is greater than 5, and we saw all this earlier. Okay, and we added one more thing here, and that's yellow flash, and that was kind of tricky to do because you're already switching that yellow LED at a really high rate. And so let's see, we're going to upload this. Okay. Oh, what's going on here? Access is denied. Oh, crap. Okay. Let's see. Okay, now here's a good. Okay, now you see here. Okay, I checked it, and you see here it says, who asked that, Jim? It says done compiling. Okay, so it's done compiling, but now it's can't open COM5. I don't know what to do now. Let's see. Stop share.
If you unplug the Arduino and then plug it back in, will that reset the COM port?
I don't think so, but I want to try anything here. You do have to set the COM port. Whoops. This must be this one.
Geez, John, what's going on here?
Okay. Now what did I do?
You stop sharing your screen, buddy.
Okay. Let's see. All right, let's try it again. No, that might have done it.
What'd you do?
Let's see.
There it is.
Okay.
We got your code plug there.
Okay, you got the code now. Let's see.
I have to read that.
Okay, stop share. And okay.
What are you trying to do? Oh, there you go. You got your camera back.
Here's my smiling face.
There it is.
All right, let's see what we got now. Hey. Okay. So there's the green. You guys all see the green flash and
Sure.
okay. And green. And there's yellow flash. We haven't seen that before.
Yeah, yellow, orange, or whatever you want to call it.
There's, yeah, it's yellowish orange. Yellow, red, red
Solid
flash, and then red. Okay. Now when I switch the switch.
Actuate the switch.
Okay, see that shuts it off.
Well, by now.
Okay, and it's not acting as a power switch. It's let's see. Okay, so we're going to go back to share screen. Let's see. Okay, so okay, it's not a power switch. The Arduino is still powered up, and it's still, when I turn the switch, well, off, if you will. We're down here in this. Where are we? We're here in this while loop. Okay, and it's testing, and that switch could be a sensor. That could be an interlock on a case. So if you open if you take the cover off, it stops things. Could be a safety switch like that. The pot, anything that's going to vary a voltage, that pot could be